Let's talk about product. And so product, like the name suggests, is the cross product of two data sets, right? So if you have two sets that you have A1, A2, B1, B2, it's all the various combinations that are possible. Now, some of them are for us would be irrelevant, right? But nevertheless, it's the underpinning of why you want to avoid to doing or why joins are so expensive, right? And why when we get back to indexing, right? When we look at performance and how to fine tune performance, we'll come back to this and say, okay, well, how can we avoid having to scan the whole table, right? Because then we get cross product. Right? So here it is. We have the cross product of both of them, and so you have all the different combinations. Whether they make sense or not, that depends what question you have, right? Depends on the predicate. Depending on the predicate, then this might make sense or not. So for instance, if you have these two tables where we have the departments and you have the students, notice that we know that Joe, Amy, and Max are in the departments computer science, math, and drama, right? Because we have their major IDs, right? So we know that everybody who has a 10 belongs to computer science, that everybody who has a 20 math, and so on and so forth, right? When we do the cross product out of this, right, we are literally considering all possibilities, right? We have both, right, values from Joe, Amy, and Max. Right now, I'm not going to do all of them, right? I'm only going to do the first three from the students. Otherwise, this would be very, very long. So I'm just only considering the first three from the left-hand side. So for Joe, Amy, and Max, I'm considering all three departments. For Joe, Amy, and Max again, I'm considering all the departments. For Joe, Amy, and Max again, I'm considering all the departments, right? And usually we only care for a subset of these things, right? But before we can even know whether some of them are related or not, we have to calculate the cross product, and then go in and says, oh, actually this makes no sense. No, this one, yes, that's the one I want, right? But first I need to be able to iterate over this, right? Of which only a subset might mean something. So typically, the product is combined with the select operator, right? That filters only the ones we care about, right? The ones that the major ID matches the ID of the department, right? So only these three out of these 9 possibilities, right, are actually make any sense. Now the combination of a select after a product is so common, right? We actually are going to merge them into a single operator called the join operator, right? The join operator takes, again, 2 arguments, the tables as argument, plus a predicate, right? So it's going to do the product, and then it's going to apply a select on it. Basically, that's what's happening underneath. But usually, as humans as we are, we abstract that idea, and we never think about the underlying thing that's happening underneath, right? Not until we have to come back and optimize it somehow, right? So here's the formal description, right? We have T1, T2 with a join with a given predicate, or in other words, you have student and major joined with this particular predicate. Okay. So here's a couple of other joins answering the question, the grades that Joe received in his courses during 2004, right? It looks like the grades are actually in one table, the enrollment table, and Joe is actually in the student table, right? So we need to retrieve that somehow, right? So here's what we're going to retrieve all the students whose name is Joe, so hopefully just one. And we're going to take the record of Joe and we're going to join it with the enrollment table. So this is going to give us all the sections, right? This is going to be all the sections that Joe is in, right? Well, I'm sorry, only the enrollments where Joe is in there, right? And we're going to now retrieve all the sections that were offered in 2004. Now we have the enrollments where Joe was enrolled, and now we have all the sections for 2004. Right, so now we need to be able to say, okay, where do these two match? Right, where do I have a section where Joe was? Where do I have a section that was in 2004, right? And which was Joe enrolled in those sections in the enrollment table, right? So we join the two where the section ID is, I believe, in the section table, and the section ID is in the enrollment table, right? Where those two match from those two outer ones, and then we project. We only really care about the grade, right? We only really care about the grade. Now, graphically, this would be represented like this. We have your students, filtered by Joe, and then join with the enrollment table. And then here we're filtering the section only with the year, and then joined again with the section ID, and then retrieving the grade. Okay. An alternative version of Q25. What's to Q25? Select student as named Joe. Okay, yeah, same thing. All right, so let's look at other ones. Here's an example of you have a department table, you have an employee table, and then we want to join on the department name, right? So we might have some folks here on the department table, some folks here on the employee table, and we map that we join on the department. So we map finance, sales. Production doesn't match anybody here. Finance matches over here. So there's so basically there's 4 resulting, and production doesn't make it in here, right? But there might be questions where I want to know about production, even though it doesn't match anybody. You bring that record anyway. So I would have information about Charles, right? But I won't have any entry on the other side, right? And we'll talk about that a little later, where that might be useful. When somebody, where questions are, at least, right, where we have, narratives, where you have those kind of qualifiers, or at a minimum, or at a maximum, when you have these kind of edge cases, right, those are clues that you do want, even the ones that don't match, right? And we'll look at an example of those. So most number of A's in any section. But what if you wanted to know about the section? Which section had the most A's? And so, as I mentioned earlier, we can join the maximum of one of them with the section, right? So we can say that 2 matches the 53 that had the 2 in there, right? Equijoins. Right. So these are the ones that we typically do, right? These are the most common ones, right? Where we match one field from one table with another field from another table, right? Where we say, well, the ones that match, those are the ones we care about. Typically, it's some foreign key referencing some primary key in some other table, but not necessarily, right? You might be joining things that are not primary, not things that are not foreign keys. All right, so we looked at that. Example: students that have same major as Joe. So here we're retrieving the. All right, so these are students that have the same major as Joe. All right, so that's a self-joining, right? That's a self-join. That's a student table that is joining with itself, right? Because I want to find, hey, here's Joe. I know what major he is. I want to find other students in the same table that have the same major, right? So that's a self-join, right? That's a table that's joining with itself, right? So it's not between 2 tables; it's between a table and itself. So first here we are retrieving Joe, the record for Joe, and we only really want the major ID because we want to filter out, again, look at all the other students who also have the same major ID. Now notice that we are renaming the major ID to Joe's major ID, and the reason is that when we do the join, we're going to have to use a predicate, right? And otherwise, if we don't use it, then we would say something like major ID is equal to major ID. That makes no sense, right? Because they belong to the same table, right? But here, because we have renamed it, we can now say, oh, okay, this is the major ID from the previous query, right? And we can use it to match the major ID from the second query. Okay. Right. So oftentimes we want to find records that don't necessarily match. Example, regular join. Where's the antijoint? I was looking for it. I don't have an example. Okay. Right. So here we have the normal join. We're putting parts of records with matching department. I get join it. But we want those records that have a match, not that you're combining. Oh, okay, yeah. So oftentimes, right, we just want to know which records match the ones that are in some other table. I don't want I don't want the data. I don't care about the data in that other table. I just want to know if these records that I'm retrieving actually have references to the other ones, right? So, for instance, it might be some foreign key, right? Some table that has foreign keys that have that point to records in some other table. Typically, I would join them, right? And that would give me fields from this table plus fields from the other table, right? But usually, so oftentimes I don't even care about the other ones. So I just want the ones. Are you enrolled in computer science? Yes, that's all I want to know, right? I don't want to know when computer science was founded, who the dean is, or any of those things, right? I just want to know, are you in computer science? That's it, right? I don't want to bring any of that information across in that query. So for instance, if we join student and department, that's going to bring the department name, how many folks are enrolled, when the department was founded, who the dean is, and I don't want that. I don't want that. I don't want any of those fields. So instead of doing that, I can change that from a join, change it to a semi-join, right? I only want the students that match this criteria, right? That match against that other table, right? So here it says I only want the students that match that other department, but don't bring any of that extra records, right, from that other department in here. Yeah, so they're actually a syntactic sugar for doing a join first, identifying those attributes between the two, and then just throwing away the ones you don't care about, right? So here, notice that we did first a join, which brings all the fields from the other table, and then we are just dropping, right? We're dropping the ones that the other fields. We only care about the ones that have the same ID and department. Here's another example. What students have taken a course with Einstein? Okay. So here we are first retrieving all the sections who the professor is Einstein. Then from the enrollment, we are retrieving those enrollments where the section matches, right? But I'm not bringing the information from the section. I only keep the enrollment fields, right? And from the student, let's see. I'm sorry. From Q38. I'm sorry. From Q38. Okay, I have all the sections, right? I have the sections that Einstein teaches. And then I'm semi-joining with the enrollment, but I only want the enrollment. I don't want to keep any of the section information, right? I only want the enrollment where the sections match the enrollment. And then I semi-join again with the students, but I don't want to bring any of the enrollment stuff, right? I don't want to know what grade you got, right? I don't want to bring any of that. Instead, I just want to keep the student where the students match, the student ID matches the enrollment student ID. Graphically, it will look something like this. Right. So here's an example of doing a regular join between the tables, where this is what we had earlier, I believe. Finance doesn't match with anyone. Sales matches with 2. Production matches with 2. Finance doesn't match with anyone. So here we have, right? We have the regular join is that we bring the name, the employee, and the department, plus now we're bringing also the manager. Right? So it's a combination of all the fields. So it might have been that we might have not cared who the manager was, right? We might have maybe just cared, is there a manager on the other side, right? Like for instance, we might have filtered out things such as finance, So let's take a look at so notice that in a semi-join, we only bring information from the employee table, right? We're not bringing any information back from the department table. So we're not bringing back the manager, and so it's a much more succinct query. So anti-join records that don't have a match. So sometimes I want to know which ones don't match, right? So kind of like the empty set, right? Which ones do not overlap? Departments that have no student majors. Department that have no student majors, right? So meaning in which departments don't have any students, and maybe we should close that department. Departments with at least one student. Or other queries, sections where nobody received an F. Hopefully this section. Consider the department, anti-joint employee. So notice that this gives me back. Notice that finance has no match in the other ones. See that? Right. So the anti-joint tells me these are the ones that have no matches, right? With the other table. A couple other examples. And professors who have never given a grade F. Unfortunately, I'm not one of them. I wish. Professors who gave an F in every section they taught. All right. Union. So union is just plain old the kind of like the concatenation of two tables, with the assumption that both tables have exactly the same field names, right? If they don't have the same field names, you can't concatenate them, right? So oftentimes you might have field names that mean the same thing but don't have exactly the same name. So oftentimes what you do is that you rename those fields so that they match. So if one says depth name and another one says department name and another one says just department, but the meaning, the semantics are the same, typically you might want to rename them before you do a union. So this is what we're doing here. We are retrieving from student, retrieving from section, the professor and the student name. They have different field names, but they're just names, right? Presumably some username names for professor and student, and we create like a professor and student table of people, right? That we unite all those names. So because they have different names, right? We rename a student name to just name. And professor as well. So here's a couple other examples that we are doing the union of these things. And notice that some of these are duplicates, right? Where we have E appearing twice in the union over there, right? And that might be desirable or not, right? So you can ask to do you can configure union to be unique or not, right? Union by default is not unique. You have to explicitly say that you want unique union. Right. So oftentimes we care about not only the ones that match, right, but also bringing those that don't match, right? That give me all the records that have foreign keys and primary keys that match between the other, but also I might want some subsets that don't match from either side of the table that doesn't match, right? Do I have an example? No, I don't have an example here. I think I have an example later on where you might ask, hey, give me all the give me the list of all faculty and their spouses, right? So that means that I need to find out, right? I need to join perhaps faculty and spouses and whatnot. But then what would happen if the faculty is not married? Then that faculty would not be listed in the results because they don't have a spouse. They would not be part of the resulting query. So typically those queries are said would be expressed as give me the list of faculty and their spouses, if any, right? If they're married, right? So they might have a qualifier there, and so that's the difference between whether this is a join or an outer join, right? Where you say, well, give me the faculty, but if they're not married, also give me the faculty anyway, right? And I'll know the other ones will be null because they have no spouse. Right? So outer joins are useful for those kind of queries, right? Where you want to, yes, give me the ones that match, but also give me a couple of ones that don't match. So other examples, I would play around with these, and probably one of these might be in your quiz. Right. Here's a couple of symbols if you want to use these in documentation. All right. Awesome.